moving in chapter 3, and now we're going to look at multiplication and division of whole numbers. So we want to look at the various models we can present. We want to relate them as inverse relationships like addition and subtraction where we want to look at their properties, and we want to look at special cases of 0 and 1. So the multiplication of whole numbers is very commonly shown as repeated addition. So 2 times 6 is 2 plus 2 plus 2 plus 2, and so on. If we can teach students that concept, it's going to greatly help them when they hit word problems, as well as when we say something like 6x. It can also be taught through arrays and area. This is for your kinesthetic learners. This is typically going to be a small population in your classroom, but it can really make that idea click. So multiplication could be utilized by constructing an array of sticks or grids and then counting the intersection points, not for the average student. Cartesian product model can be thought of, and we're going to look at a little bit of that. So the repeated addition, that is your mainstream. Most students are going to connect with this. And it's really important that you don't just introduce multiplication facts. Don't just pull out flashcards when we start. It's really important in the beginning of multiplication, you relate that to doubles. And so 3 times, 2 is 3 plus 3. We really want to drive that repeated addition home, and we can do that easiest with the idea of doubles. Once you move from doubles, we're going to start adding larger numbers of doubles. So if I have 3 times 4, I have 4 groups of 3, which is 3 plus 3 plus 3 plus 3 when I add them all together. The repeated addition model can also be shown on the number line. So when I'm showing repeated addition, I could have 4 groups with 3 dots in each, or I could start drawing them on the number line themselves. In an array and an area model, if I do 4 times 5 equals 20, notice I have 4 vertical columns and 5 rows. And so they're counting up by row. So I have 5, 10, 15, 20. So they're counting by the numbers that you've got in the vertical side of the array. So if it was 2, they would count by 2s. And this is why we make skip counting by 2s, by 3s, by 4 so important, because it's going to relate back to this array idea. An area model is like an array, but instead of dots, we have squares. So they're still counting by 5, 10, 15, 20, but I don't have dots on there. I'm just counting the number of squares. For any whole number, n times a is going to be the repeated addition of that a value. For Cartesian model, we're going to look at 2 web-based courses here. And if you're looking at taking one of these courses, and this is, again, it's a scenario, right? We're relating to something in the real world that you may have experience with. To look at the number of possible schedules, we can start looking at tree diagrams. So this is the Cartesian product model. This is not for most students. This is probably not what you're ever going to use to teach this. But it is a possibility when we're looking at those word problems where we have words and not numbers. This is a counting principle. So when you get to teaching the counting principle in, like, say, 6th grade, this might be helpful, but this is not for your average multiplication learner. So what I also want to know is it doesn't matter what order you multiply things in. And it's also, if I multiply a times b, then I know that a times b is going to be done. So this is an alternate definition within. So the number of a times b, the quantity of, that's what this is telling us, that a times b is the quantity of the things in group A done b times, or the quantity of things in group B done a times. So it is a product, and A and B are referred to as factors. It is so helpful if at the elementary level we start saying the word factors. So 2 times 3 is a product. We want to say 2 times 3, or we want to say the product of 2 and 3. So start interjecting those different terms in your vocabulary. So when they get up there in the higher level math, they say, oh, I know what a product is. And if you say 2 and 3 are the factors, then they're going to know what factors are. And that's really going to help them connect the dots over the course of their elementary education. And notice we're not multiplying sets. No, we don't multiply sets. The closure property means if I take a whole number and I multiply it by a whole number, my answer is going to be a whole number, just like we saw with addition. The commutative property means it doesn't matter the order I multiply in, it's going to be the same answer. The associative property, notice the parentheses are grouping two different things together on either side. And it doesn't matter how we group them because we're still going to get the same answer. Now, the identity property, in addition, we added 0. In multiplication, we're multiplying by 1. Why? Because an identity property means you get what you started with. And in multiplication, if I do 2 times something, 2 times 1 will always be itself. If I'm doing the 0 multiplication property, that means what will you multiply to get 0? Well, that's going to be multiplying anything by 0. So that's going to be a new property we're introducing here. We can show the commutative property of multiplication for students who are hands-on learners by having them arrange blocks. So I could have 3 rows of 5, or I could have 5 rows of 3, and we can show them that these two statements are going to be equal. For the associative property, we're grouping things together. So it's this three-dimensional idea of what's being grouped together. This is probably not going to be an activity that a lot of your students grasp. But when you have those higher level students who maybe finish their work early, this is a great thing to assign to them, to have them work on grouping things together and seeing if they get the same answers. The distributive property is something we've added into the lower levels a while back. It is so, so important. We want them to know that 5 times 3 plus 4 is 5 times 3 plus 5 times 4. So we want to start teaching them to break those arrays up and those area things up, and that we can sum them back together. So we want to start teaching the distributive property. If you're teaching those upper level grades in elementary, you're going to have to start saying distributive, and you're going to have to start teaching them that distribute means if I tell you to distribute the papers to the class, you give everybody in the class a paper. It's the same idea in the distributive property. You're multiplying everybody by what's in front. So that paper is going to everybody through multiplication. You can't skip anybody because they don't have their notes. So relate it to those kind of ideas to your students so that it clicks. I distribute papers, everybody gets one. In math, everybody gets an A by multiplication. And it works the same way for subtraction, because when you distribute, you're multiplying everybody inside the parentheses by A. So the parentheses is your class, and A is the paper you're handing out to your class. Because the commutative property holds for addition, B plus C times A would be the same thing as if I had A written in the front. It doesn't matter what order things go in. As long as everybody is getting an A, we're all happy. When the distributive property is written from the left side to what's on the right side, that is going to be slightly unique because I'm going from the distributive property form to the factor form. So when I'm bringing that A out, I'm picking up papers for my class. So when I'm picking up papers from the desk, that's going to be your factoring process. So here's an example. We want to use an area model to show this. So if I'm using an area model, my multiplication, is going to be broken into an area. So x times z. So xz is represented by a square of side x and side z. That's my xz. The square xw is represented by a rectangle with side x, width w. And then same thing here, yz is represented as a rectangle with length y, width z, or however you want to distribute length and width. So this is how we show an area model, because we say the sum of these parts is going to be the whole. So the distributive property of multiplication then shows that we do not FOIL this, that everybody gets an x, so z and w get an x, and everybody gets a y, so z and w get a y. So we're walking away from the idea of FOIL, and we're trying to show that everybody gets one. In the division of whole numbers, I'm looking at divisor number subsets. So I'm taking some larger number and I'm dividing it into smaller groups. And so then I have the missing factor model, where maybe I'm going to relate division over to multiplication. I have the repeated subtraction model, which is great for everyday learners. So if I do the set partition module, I'm going to have my whole group of 18 cookies, and I'm going to put them in groups. So this is great with hands-on things, and you're going to tell them, put them into 3 groups. They go 1, 2, 3, 4, 5, 6. And they keep working until all of the 18 cookies are in these 3 groups, and they can physically see 18 divided by 3 leaves 6 cookies in every group. So it's fantastic to have for that. It can also be done if you don't have manipulatives. It can be done by drawing. So they could cross out a cookie every time they draw it into the new group of 3. In the missing factor model, you really have to have students that are very strong in multiplication facts. So if we teach them that if I want to do division, so I want to divide 18 cookies into 3 groups, 3 times what is 18? Well, we know 3 times 6 is 18. So if I take 18 cookies and I divide it into 3 groups, my answer is 6. The everyday learner is not going to catch this, and this is definitely not something to show them at the very beginning of division. We also know that division of whole numbers is closed. If I take a whole number, I divide it by a whole number, I get a whole number. So when I'm giving the terms, and this is really a place where I've seen a weakness in our curriculums as a nation, A is the dividend, B is the divisor, and C is the quotient. A lot of times we just want to keep saying division, division, division. It's really important to start saying, hey, that if I take A and if I take the dividend and I divide it by the divisor, I get the quotient. So just trying to work those into your everyday terminology in your math classroom, especially the word quotient, because when they get to word problems, they're going to struggle with seeing quotient. And when they get to expressions in like 5th and 6th grade, it's going to be a struggle if they haven't ever heard a teacher say quotient instead of division. And then we also want to start recognizing that division is a fraction. A fraction is division. So we want to start representing that symbolically. So again, sprinkle it into your math lesson. Throw them for a loop. Say 6 divided by 2 is 3, but also write it as 6 over 2. And, say, hey, 6 over 2 is just 6 divided by 2. That really helps them, again, scaffold that knowledge all the way up. If I have the repeated subtraction model, what does that look like? Well, I'm going to keep subtracting even groups until I figured out where I'm at. If I'm looking at a division algorithm, I want to be given any whole numbers, say A and B, where B is not equal to 0. There's some unique whole number where the quotient and a remainder. So this is where we start saying, hey, you might have a remainder. Maybe it doesn't divide evenly. So when A is divided by B and the remainder is 0, we say that A is divisible by B. But if there's a remainder, we have something different happening. So if 123 is divided by some number and the remainder is 13, what are the possible divisors? Well, I'm going to look at this as something plus 13 is 123, the product of 2 numbers. So I know that that product, something has to be bigger than 13. So from the definition of subtraction, I can take that 123 and subtract the 13 over so that B times Q is 110. So what 2 numbers can I multiply to get 110? Well, we know there's only one number that's greater than 13 that this actually works for and is a factor. So I'm going to show you all the pairs of 110, and I'm going to look at the ones that are greater than 13. So I have 5 and 22, 2 and 55, and 1 and 10. So I should see that at this point, 55 and 22 are going to be the only possible because the values for B have to be greater than 13. So if I'm relating them as inverse operations, we want to think about if I do addition and I get subtraction, I'm basically undoing what I just did. If I do subtraction, if I do multiplication and then I do division, I'm right back where I started. So we want to start using the word inverse as we start seeing that happening. Now we want to remind students we cannot divide by 0. So 0 is not okay. If it's something divided by 0 where 0 is a second number, it's not okay. If 0 is the first number, you get 0 for your answer. And also, we cannot take 0 and divide it by 0. It's undefined. And it's so important to start saying undefined, teachers. If you can say undefined, that makes, again, their algebraic career is so much easier because they recognize a term. They've heard it used in their lower level classes. And it's just sprinkling in these terms into your lectures with students, sprinkling in the practice. And maybe when they're at the board, we're just going to throw that word out there. We're just looking for you to start sprinkling some of these ideas. With the order of operations, if there are no parentheses present, multiplication is done before addition and subtraction. And they go in the order that they occur from left to right. So all these social media memes we see where they're like, oh, but you can't guess it. The key is always moving left to right.